Okay, let's talk about distribution. Would you please put this in your graph notebook? Call it distribution and put today's date, September 11th. And let's do an example. This is just a review. Some of you are probably very good at this, and some of you might not have done it before, or you come from a lot of different middle schools. Let's say that we had 3 times 2x minus 5. So if you have a number directly to the left of parentheses, that means multiply. Notice there's no plus sign here, no negative sign here. So because the 3 is directly to the left of the parentheses, that means multiply. So we're going to go 3 times 2x, and then we're going to go 3 times negative 5. The long way to write this, and I would like you to do it just for this example, would be 3 times 2x minus 3 times 5. Why did I put a minus here? Because this is a minus. Okay, so that would be 6x minus 15. So what we call these 3 expressions, and I'd like you to write this down also, these are all equivalent expressions. And equivalent means they are equal in value. Okay, so that means if I put in any number for x, all 3 of these would yield the same answer. So equivalent means equal in value. So they look different, but they have the same value. Okay, now let's do example. That was example 1. Let's do example 2. And what I'm going to show you here is that most people skip this step. It's a good step to see how distribution works, but we don't usually write it. So let's do another one. Let's see if we're brave enough to do a fraction. 5 over 4 times 6x minus 2. Actually, this step would be good here. Let's do it. 5 over 4 times 6x over 1. And then it's going to be minus, because that's minus, 5 over 4 times 2. And again, remember, we're not using decimals. So we're going to keep all this in fractions. And I want to show you a shortcut. You could say that this is 30x over 4 and then simplify it. But what's easier is to say, hey, if 6 and 4 were their own fraction, I could simplify them already. I could divide them both by 2. So this would become a 3, and this would become a 2. In other words, if I wrote 6 and 4 as a fraction and divided top and bottom by 2, I'd get 3 over 2. So I can just do it right here, and that's called cross-canceling, and it's faster. So 5 times 3 is 15x on top, don't forget the x, over 2, minus, and look, I can do it again. If 2 over 4 were their own fraction, I would divide top and bottom by 2. So I'd have 1 over 2. And I'll do that up here. If 4 over 2 was its own fraction, I would divide top and bottom by 2. And I would get, oops, I did that backwards. If 2 over 4 were its own fraction, I would divide top and bottom by 2. I would get 1 over 2. So see how I just did that right there in my head? That's standard math practice, by the way. So now I have 5 times 1, 2 times 1. So that gives me 5 over 2. Now, could I have done that without writing all that out? Sure. Let's see, 5 times 6 over 1. I could have cross-canceled, and I would have gotten 3 over 2. 5 times 3 is 15, so I would have gotten 15x. 2 times 1 is 2. Then I could have said 5 over 4 times 2 is 10 over 4. 10 over 4 simplifies to 5 over 2. So I could do it without that step if I want, but that step is very helpful. So there's my answer. Now, by the way, all 4 of these are equivalent expressions. Okay, let's do another one. You're writing these down, right? Example 3. Let's do 3 times 1/2 x plus 8. Okay, so we're going to go 3 times 1/2 x. If you want to just do that, you can. So that's just going to be 3 over 2x. 3 times 8, 24. Done. Okay, here we go. Example 4. Go ahead and do it yourself. And then see if you got 10 over 7x minus 45. Right? These are equivalent expressions. These two. Okay, example 5. Before we do example 5, we need to make sure that we know something. So this is, let's call this a timeout. You're going to write this too. What is x times x? It is not 2x, because 2x equals x plus x. X times x. Do you remember that these are both x to the first power? So x times x is x squared. Definitely memorize that fact. We're in quadratics now. We're going to have a lot of x squares, so we need to know that x times x is x squared. So here we go. Example, are we on 5? Yeah, example 5. X times x, x squared. X times 3, example 6. When you have 5x times 6x, you multiply the coefficients and you multiply the variables. So that becomes 30x squared. Now 5x times negative 12 is negative 60, but you got to keep the x, negative 60x. Okay, so if there's an x out here, then you have to multiply that x by both things, and you have to multiply the 5 by both things. Okay, let's just do a couple more. Example 7. Oh no, fractions. All right, so let's write this one out the long way. 6x over 5 times 3x, and I'm going to put an invisible over 1, but you don't have to do that, minus 6x over 5 times 1/2. Now, why did I put a minus? Because there's a minus there, okay? 6x times 3x, 18x squared. 5 times 1, 5. 6x times 1, 6x. 5 times 2 is 10. But look, this 6 and this 2 can simplify. If I divide top and bottom by 2, this becomes a 3. That becomes a 1. So I get 3x over 5. Now, if you did it the long way, you would get 6x times 1 is 6x. 5 times 2 is 10. And then you would divide top and bottom by 2. And you would get 3x over 5. So you'd get the same thing. It would just take an extra step. Okay, last one. You're doing it, right? I'm going to write this one out. And I can simplify here. Right, 2 times 3, 6. This canceled, so it could be over 1, but I don't really need that. Then times, 2x over 3 times 12 over 5. Ooh, 12 and 3 cancel. So 3 divided by 3, 12 divided by 3. 2x times 4. Oops, that's a minus. Dang it. 2x times 4 is 8x. 1 times 5 is 5. Oh no, I forgot my squared. There we go. 6. Oh my gosh, you can't see anyway. 6x squared minus 8x over 5. Okay, because x times x was x squared. Okay, let's keep going. Over here, they're about to ask us to graph our functions from these. So if I have to graph 8a, I need all these numbers to fit. And they said, place your axes so you can see all 5 points, identify your scale, write your explicit equation above the graph. So what I'm going to do with this, and you may want to do these in your graph notebook, but I want you to notice the size of their graph. So starting on the bottom row, they have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, if you count the top and bottom. So you want the ones in your book to be the same size. So here's the bottom. Well, you can't see that. Here's the bottom, and I'm going to count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I can't go higher than that. And then here's where they started. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So what that really means is I have 10 spaces to deal with, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, actually, I think I did an extra. So I have a scale of 10 here. So I have to go up to, in the book, it says it goes all the way up to, on the y-axis, 1024. So if this is 0, and I have 10 things to work with, one thing I want you to keep in mind is we don't do like weird numbers if we have to make the scale. But they all have to be an equal distance apart. So, I mean, I could divide 1024 by 12. That'll get me an idea. But I want to stick with, here's what we usually stick with when we do scales. We stick with like 2s. Sometimes we can do 4s, 5s, 10s, 20s, 25s are good, 50s, 100s. Those are about the only things that we use, or, and then 500, 150. After that, we can use like 150, so on. So I can't use 100 here, I don't think, because I run out of space. Let me just double check in the book. Can I use 100? 100, 200, 300, 400, 500, 600, 700, 800, 900, 1,000. I don't have enough space to use 100 because it goes over 1,000. So what's my next option? I could use 150 or I could use 200. I could use 150. Why not? So I'm going to have to do a little adding. So this one's going to be 150, 300, and then 450. Boy, this is taking a little adding. 600, 750, 900, 1050. Okay, so I used most of my space, right? That's pretty good. Now, if I go across here, it says it starts at x equals 6. So that's going to work out perfect. So what I'm going to do, 1, 2, 3, 4, 5, 6. So I'm just going to go ahead and start it at 6. 6, 7, 8, 9, 10. All right, so let's go. The first one is 64. So 664 is, you know what? I don't like that. Let's go back. Do this part of the video again. Okay, so let's look at number 10. So number 10 says to graph the functions from 8 and 9. Okay, by the way, I didn't do a video on 8 and 9 because I think you already know how to do that. So for number 8, let's look at this. This has, if you count this as 0, then, if you count the bottom as 0, then this goes up to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Same thing, if you count this as 0, this goes to 10. But they want us to identify the scale and show all 5 points. So I'm going to do this in my graph notebook, and you probably want to also. So I'm just going to draw, here's the top, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that's how much space they gave me. So if I look at number 8, my Y's go to 1,024. So my first thought would be like, oh, I could use 100, 100, 200, 300, 400, but I really can't because the 10th row would be 1,000 and it would go above the graph. So look, when we need to change the scale on our axes, every number has to be an equal distance apart. And here's usually what people use. Of course, they can do it by 1s, 2s. You can number it by 5s, like 5, 10, 15, 20, 25, 30. But, yep. And then, oh, you know what? Sometimes people use 4s. 4s are okay. 10s. People don't usually use 15s, but they can use 20s, 25. The next thing people usually use is 50. Occasionally, you could use like a 30 or a 40 if there was a good reason. Then the next thing people would use is 100, then like 150. Then maybe people use 200, 250. Like what I'm saying is these are your choices for your scale. So if I numbered this, I would do this would be like 20. This would be 40, 60, 80, 100. Now, if I need to get all the way to 1,000, I just figured out over 1,000 that 100 won't work because it would be 100, 200, 300, 400, 500, 600, 700, 800, 900, 1,000, but the graph goes to 1,024, and they only gave me 10 by 10. So my next good choice is 150. So I'm going to number this by 150s. And the other thing is, where can I put my y-axis? Well, if I look at my x's, they're all positive and they start with 6. So I'm going to go ahead and put my y-axis right on the edge of the graph because I don't need any negatives. So then this would be 150, 300, 450, and then this would be 600. I'm going to write the 450 kind of small. And then this would be 750. I'm adding 150 every time because 100 was too small. So I went to the next available one. 900. You can add 150s in your head, right? Oh, and then this is 1,050, right? Yeah, 1,050. Now, here's an interesting thing. This starts at 6. And I don't know, I don't want to waste all this space. So here's something you can do. You can draw a zigzag like this, and I can say that this is 6. As long as I draw that zigzag. Actually, I didn't draw it very well. It should look more like that. Okay, that's actually kind of a math symbol, and it means I made a cut in the axis so I could show my graph better. Now, how many do I have? 6. Can I go by 2s? 8. Can I go 6, 7, 8, 9, 10? Yeah, why not? I'm going to spread it out. 7, 8, 9, 10. So now I'm going to graph my pairs. 6, 64. 64 is not quite halfway to 150. So 6, 64 would go there. 7, 128. Okay, still not quite to 150. So I'm going to put it right there. 8, 256. So 256 should be somewhere between 150 and 300, but closer to 300. 512. Well, here's 450. So 512 is going to be a little above 450. And then for 10, it's 1,024. So here's 1,050. There's 1,024. Okay, then it said to write the equation. And let's see, this was f of x equals, I forgot to figure out what the initial value is. But I know it's times 2 to the x. So let's see. It is just 2 to the x. Right? Because if I do 64, if I work backwards, you know how 64 was term 6? Let's try this again. 64 was term 6. So that means terms 5 would be 32. Term 4 would be 16. Term 3 would be 8. Term 2 would be 4. Term 1 would be 2. And term 0 would be 1. So it's just 1 times 2 to the x. And, should I have connected these? Technically, no. Don't connect. Because here, they didn't tell me what's in between. This is what we call discrete. It's just a set of points. So I probably should have just left the points without connecting it. Finally, they said to list the characteristics in the table that helped us identify. Oops, that was the wrong one. Finally, they said, add any additional characteristics you notice from the graph. So I'm going to put that I noticed that it's a curve and that this rate of change, you can't see that. I'm going to put it's a curve, and this rate of change from 9 to 10 was like steep. Like this rate of change was real lame, right? Just a little. But then here it's like whoosh. Okay, so that gives you an example of how you're supposed to do that. Oh, here's an important thing. Hopefully you're still watching the video. On letter, on letter F, you do not need the explicit. Okay, and on letter C and F for today, not C and F, sorry. On B and F, it's okay if you don't get the equations, because we're going to work on that on Monday. Sorry, let's write that again. One thing about your homework, so hopefully you're still watching. On 8B and 8F, 9F, 8B and 9F, it's okay if you do not get the equations, but I still want you to do the graphs. Okay, I'm going to add one more thing. On all of 8 and 9, I want you to tell me, even though it doesn't tell you to, I want you to tell me the common difference, if it has one, or the common ratio. Or if it's quadratic, then I want you to make sure that you show me the first and second differences. And I think you can just put those in the book. Okay, so for example, I'm giving it away, but on 8B, it's a quadratic. So you would show me the first difference, like I think it goes from like 36 to 49. So you would show me that that's plus 13. Then it goes 49 to 64. So you would show me that that's plus 15. And then you would show me the second differences. Okay, so you're going to pick one of these. The common difference, if it's linear, the common ratio, if it's exponential, the first and second differences, both, if it's quadratic. So you're going to have to figure that out a little bit. Woo, this was a longer video than I thought it would be. I hope I have time to upload this. Here we go. I hope it recorded. Holy cow.